Guys, Mr. Sonnenberg here. Today we're going to be talking about combustion, corrosion, and the law of conservation of mass. So we'll dive in and we'll first talk about combustion. So take a look at the flame over here. Basically what that flame is letting you know is when something combusts, well, it's going to start on fire. So combustion, let's talk about first what it is by definition. Well, combustion is a highly exothermic combination of a substance with oxygen. So highly exothermic meaning that it's going to give off heat. Okay, so exo is kind of talking about the give off, and thermic is talking about the heat. So basically whenever we combine these highly exothermic substances, well, when we combine certain substances with oxygen, what's going to happen is it combusts and it'll start on fire. We need oxygen to start a fire, so remember that oxygen is going to be key. So if we just take a look down here at, right here at this diagram and such, what we're going to see is methane. So what I've done here is I've provided you with an equation. So we have the formula here, okay. Alright, and that's a chemical equation. And we have these formulas. And then I have the word equation here. Okay, I'll just call it the WE. But basically what that is right here, I'm going to underline first, that's methane. But now what happens to methane? So it's a hydrocarbon, it is carbon and hydrogen. What happens when I add oxygen gas to it? Poof, it combusts. And so what's going to happen is we're actually going to produce in combustion reactions, we're always going to produce carbon dioxide gas and water vapor. So carbon dioxide gas is going to be the CO2 here, and then the water vapor is going to be right here. So now, basically, if we look at the word equation, methane plus oxygen is going to react to produce water and carbon dioxide. Okay, remember water is going to be in the form of a gas, so it's water vapor, but these combustion reactions are always going to produce that because, especially in these hydrocarbons, because carbon, hydrogen, and oxygen are going to produce those. But anyways, it's highly exothermic, so it gives off heat. So think of, when you think of combustion, think of fire. Okay, so combustion reactions, I'll just read this, always involve molecular oxygen, or O2. Anytime anything burns, in the usual sense, it is a combustion reaction. Combustion reactions are almost always exothermic, so they almost always give off heat. Okay, so that's combustion. Okay, so we know that's fire. You have to be able to identify those equations that I showed you on methane, and the word equation to be able to identify from the list that those are combustion reactions. Now let's talk about corrosion on the other side, though. Corrosion, take a look at the beat up old car. If I ever have my truck at school, you take a look at my truck. I've got rust on the fenders. Yeah, I've kind of covered it up or whatever, but if I ever try to sell it, there's no covering it up, that's for sure. It's getting a little flimsy back there. But rust is basically the oxidation of metals or rocks in the presence of air or moisture. So basically, if we expose a metal to moisture, let's say leave it outside, so like that car, well, it had moisture, so say water vapor, or water, rain, water, snow, whatever hit it, and if we exposed it to also oxygen plus the iron, well, what it's going to produce is going to produce rust. Okay, so let's just take a look at the equation for rust here. So basically this is going to be our iron right here, okay, this Fe, but if we combine it with and this is just showing basic, I didn't add everything in here, but basically if we have oxygen as well, then we produce iron oxide. And then now what happens if we combine that with water, we're going to produce rust. Okay, so that's a corrosion reaction. So you need to be able to identify that iron or a metal plus oxygen and moisture is going to produce rust. Okay, and that's going to be what's important. So how can we prevent corrosion? Well, it's pretty cool. I don't know if anyone's built anything out there before, but I know my dad was a carpenter, was a contractor, owned his own business for 20 years, so I've been helping him since I was 12 years old. And him and I built my house together, and so we'll probably build my next house together as well. But Galvin, he always made sure that he said, okay, well, I need to go pick up some nails. So usually I'd pick up regular spikes for the interior structure. But what happens is when you're working on the exterior structure, you have to use what's called galvanized spikes or galvanized nails. So basically what galvanization is, it's the process of coating metals with a thin layer of zinc. The reason we use these galvanized nails was that electroplating, or that covering with the zinc, the galvanization, actually prevents the nails from rusting, because their oxygen and the moisture is not going to affect the zinc. So other ways you can do that, though, is you can prevent corrosion by applying a thin layer of paint. Okay, so we can paint things. So if you see posts or on fences, posts that are painted or they're very shiny metallic, well, that's because they're either covered with zinc or they've been painted, and with hopes to prevent rust. But what happens if the paint chips? Well, if the paint chips off that, then now the rust can expose and weaken the whole structure. So I know galvanization, I know the importance of that because of my dad telling me that I need to get galvanized nails so they don't rust or my structures would fall apart. So galvanization, pretty important. Now, just want to talk about, in these chemical equations, the law of conservation of mass. So basically you need to be able to identify the law of conservation of mass by definition. So in a chemical change, the total mass of the new substance is always the same as the total mass of the original substance. So basically what happens is, if we split up our chemical reaction into reactants on this side, okay, and products on this side, and we do what we call a simple left side, right side. So here's my left side, here's my right side of the equation, and it's separated by this arrow here. So my reactants are over here, my products are over here, all of these. And basically I say, okay, well, I have carbon, I have 1 carbon. How many hydrogens? Well, there's a 4 down there, so I have 4 hydrogens. How many oxygens? Well, 2 times 2 is going to equal 4. And then here, how many carbons? Well, I have 1. I have 2 oxygens, so we would just take that right there first. Now I have 2 times 2 hydrogens, which is going to equal 4, so that's good. But then I also have 2 times 1 oxygen. So now I have to say, so that equals 2 plus 2, and then that equals 4. So what I have here is I have an equal amount of carbons on each side of the equation. Okay, so those are good. I have an equal amount of hydrogens on each side of the equation, so those are good. And equal amount of oxygen. So what I can say is this is balanced. Okay, and each one of those elements has its own mass. Like hydrogen's mass is equal to 1.01. Well, each one of those is going to have the same mass. So the mass on the right side or left side is going to be the same as the mass on the right side. So that's the law of conservation mass, saying that in a chemical reaction, that the products and the reactants still have to have the same mass. Okay, you can't add or miss out or leave out anything. It has to have the same. So what happens here has to move there, and the mass will remain the same. All right, guys. So what I'm going to show here at the end is a little video that you can watch there's a little bit on combustion and a little bit on corrosion as well, I believe. So I'll leave you with that. Make sure you watch the whole thing. Thanks. Bye.
Hello, I'm Jeff De La Rosa, Managing Science Editor at World Book, and I'm here to explain what causes something to rust. Rust forms when iron or steel is exposed to the air. Iron in the metal combines chemically with oxygen from the air to form iron oxide, the brittle brownish-red substance that we call rust. The rust reaction happens much more readily in the presence of moisture, which is why items that rust easily should not be stored in damp conditions. Rust can also be avoided by covering the metal in a thin layer of oil or another substance that prevents contact with the air.
Well, today I'm going to demonstrate a combustion reaction right in front of you. Okay, this is called methane bubbles. I'm just generating some methane bubbles right now. So that looks to be enough, so I'm just going to come over here and turn them off. Now, when we have a combustion reaction, we have to have what we're going to combust, which is the gas inside these bubbles, and we need an ignition source. So what I have is just a lighter here. I have some methane bubbles. I'm going to ignite them. Okay, so here we go.